Welcome to Math Infinity. Today we will learn about a special number that is called perfect square. So what do we mean by perfect square? A non-negative integer which can be expressed as the product of an integer by itself is called a perfect square. Means if we multiply a number by itself, then the number obtained is called a perfect square. For example, 1 can be written as 1 multiplied by 1, 4 can be written as 2 multiplied by 2, 25 as 5 times 5, 100 can be written as 10 times 10. So 1, 4, 25, 100, these are perfect square numbers. If I take number 15, I can write it as product of 1 and 15 or product of 5 and 3. I cannot write it as the product of two same numbers, and therefore 15 is not a perfect square. So perfect squares are written as, we can write them as 3 square, or I can write it as 5 square. So instead of writing 5 times 5, we write 5 and in exponent form 2. Or in general, these are written as n square. So this term square, it comes from the geometrical shape. A square is always known as a polygon or a quadrilateral whose four sides are equal and diagonals are also equal. So it has length equal to breadth, and its area is written as A times A, where A is side length. And the unit of measurement of area is square units. So if the side is say 5 centimeter, then area of the square is 25 square centimeter. So when we say square centimeter, it means this is the area of a square of side 1 centimeter. And since there are 9 unit squares, so area becomes 9 centimeter square, or area becomes 25 centimeter square. So this is a perfect square chart. You can see the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. These are the perfect squares. So multiplying 6 by 6 gives you 36. And you can see the unit digits 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So all perfect squares, they end with 1, 4, 9, 6, 5 or 0. So here I have written that in base 10, a square number can end only with digits 0, 1, 4, 5, 6 or 9. So last digit would be 0 if the square ends in 0, 0. So for example, if the square ends with 0, 0, this is the perfect square 400. So it means this is the square of number which is ending at 0. Similarly, if the last digit of a number is 1 or 9, it means a square ends in an even digit followed by 1. So if I make the square of say 21, so it would be 4, 4, 1. So it ends with an even digit. 4 is an even digit and followed by 1. Followed by 1. Okay. So similarly, I have written all the properties. If last digit is 2 or 8, then square ends by 4 because 8 square is 64, 2 square is 4. Similarly, 3 square is 9, 7 square is 49. So number ending with 3 and 7, they give the square number ending with the digit 9. Now I have written some of the properties of square numbers. If I know the square of any integer, then using this equation, I can find the square of next integer. So it means knowing the square of one integer, we can calculate the square of next integer. For example, if I take n is equal to say 7. So what is n minus 1? N minus 1 is 6. So if I know the square of 6, I can calculate the square of 7 without multiplying 7 by 7. How can I calculate? I can substitute n is equal to 7 here. So 7 square would be equal to 6 square plus 6 plus 7. N is 7 and I know the square of 6. So it is 36 plus 6 plus 7 and this is equal to 49. So if I know the square of any integer, I can find the square of next integer without actually calculating it. And this equation you can verify using algebra, that left hand side is always equal to right hand side. You can take one more example. If I take n is equal to 10, it means n minus 1 is equal to 9. So 10 square can be calculated as 9 square plus 9 plus 10. That is 81 plus 9 plus 10, and we know that this is equal to 100. Second property is when we write a perfect square, say 25, it means 25 dots are arranged in a square. So when I talk about any perfect square, say if I talk about perfect square 9, it means 9 dots can be arranged in a square. So I can arrange 9 dots in a square. Similarly, 25 means I can arrange 25 dots in a square. It means every horizontal line has 5 dots and every vertical line has 5 dots. I can arrange these 25 dots in a square. So this is the second property. That's why we call them square, perfect squares. Next property is that if we arrange dots in triangular form, we get the following pattern. Triangular form means, say this is one dot, then triangular I make 3 dots, this was one, then in triangular form I'll make next 3, then next pattern has 1, 2, 3, 4. So here I have 1 dot, here 3 dots. When we arrange them in triangular, in this I have 1, 2, 3, 4, 5, 6, 6 dots. In this pattern I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. Similarly, if I make the next one, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and then 11, 12, 13, 14, 15. I will have 15 dots. Now you see the interesting pattern. If I add these two consecutive triangular numbers, I get 4. If I add these two consecutive triangular numbers, I get 9. Similarly, if I add these two, I get 16. If I add these two, I get 25. So what I am getting? I am getting 2 square, then 3 square, 4 square, 5 square. It means sum of any two consecutive triangular numbers is a perfect square. So you add any two triangular numbers, they have to be consecutive, then number obtained will always be a perfect square. This is interesting. Fourth property is that sum of first n odd numbers is always n square. Odd numbers, what are the odd numbers? Which are not divisible by 2. So 1, 3, 5, 7, these are odd numbers. So if I add odd numbers, say n, if I take it 3, so if I add 3 odd numbers, so what is the sum? 1 plus 3, 4 plus 5, 9. So I get n square. Am I getting 3 square? Yes. If I take 5 odd numbers, so 1 plus 3 plus 5 plus 7 plus 9. 5 odd numbers, add them together. 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. Yes, you have got 5 square. That is n square. Next property is the difference of two square numbers is the product of their sum and difference. Do you recall any algebraic identity? Yes, the identity is a minus b whole square is equal, sorry, it is a square minus b square equal to a minus b into a plus b. This identity will not work here. So let us remove this. So difference of two square numbers is the product of their sum and difference. So for example, if I write 6 square minus 2 square, so it will always be equal to 6 plus 2 into 6 minus 2. You can verify it. 36 minus 4 is 32. 6 plus 2 is 8. 6 minus 2 is 4. 8 times 4 is also 32. So difference of two square numbers is always equal to product of their sum and difference. It helps you when you calculate when you large numbers. When suppose a is equal to 57. So you are calculating 57 square minus 7 square. So it can be written as 57 minus 7 into 57 plus 7. And then it becomes easy to calculate. So it is 50 into 64. So it becomes easy when we use this identity. And that's all about it. There are many other properties as well, but for now, uh, up to school level, I think these are the properties which we use in school curriculum. So thank you so much. God bless you.